We're going to run a chi-square test. This is 12.1.15. And so here's the situation we have. We have a distribution of how riders were killed in a motorcycle accident, and the location of the injury, and how many people died out of 2,093 riders not wearing a helmet. And that's what we have here. This is the distribution for not wearing a helmet. And what we want to know is not wearing a helmet a reason why people die more than the normal percentage of people, or proportion of people who die in these locations, right? So when someone dies in a motorcycle accident, 57% of the time it's in multiple locations, 31% of the time it's the head, 3% neck, and so forth, right? And so we're trying to see if this distribution follows the same distribution here. If so, then wearing a helmet doesn't matter, right? Not wearing a helmet doesn't matter. So that's what we want to compare. And so that would be our null and alternative hypothesis here. Looking at, does the distribution of fatal injuries not wearing a helmet follow the same distribution, or it does not follow? And so what we have to do is calculate what we would expect to see in the normal situation. Here is our normal distribution, or not normal. Here is the distribution for those who fatalities in a motorcycle accident. And so what we do is we take those percentages multiplied by the n value here to get your expected counts, and that's the ones in green right here. After you have your expected counts, you can compare the expected to the observed, and it looks kind of close, but maybe that's why it's hard to tell, because these are just samples. These are not, again, our entire population. So we're going to calculate a chi-squared statistic, and to do that, you put your observed and expected into StatCrunch, which I have here, and then you go ahead and run a goodness of fit test, chi-squared test, right? And then the observed, I have it in the observed column, expected in the expected, that's how I named it. And then you just compute, and you get your chi-square value, 126 in this case, and you get a p-value that it's less than 0.001. And since that p-value is small, right, we end up with this big chi-square value, a small p-value, it's less than 0.001. We then conclude that we're going to have to, we would then reject, right? And so our conclusion here would be, the conclusion here would be to reject, right? Because our p-values are way less than 0.01, very small. The chi-squared was 126 point something. And so since we're rejecting, coming back here, right, we're rejecting this one here. This is being reject. So what we're saying is that there is sufficient evidence, right? There is sufficient evidence that the distribution of fatal riders not wearing helmets does not follow, right? And so that's what we have, does not follow the same distribution. So that's what we're looking at. Of course, there's some other questions here, but just looking at comparing them. And again, it doesn't tell us which one does not follow. It's just saying that we know it does not follow. So our conclusion is that not wearing a helmet does have an effect on it increases your likelihood of having a fatal injury. And you can see that, compare them, that some of them are pretty different than the other ones.